Did you know that the energy stored within a single uranium atom is nearly 10 million times the energy stored within a single coal atom? This fascinating fact is what led to the birth of nuclear energy. Let's journey back to the 1930s when the concept of nuclear energy was just a theory. Scientists discovered that nuclear fission, the splitting of the atom's nucleus, could produce massive amounts of energy. This was a monumental discovery, one that promised a future of virtually limitless clean energy. Fast forward to the 1940s, the era of World War II. It was during this time that the United States developed the first functional nuclear reactor as part of the Manhattan Project. This project, initially intended for the development of nuclear weapons, also laid the groundwork for the future of nuclear energy. In the 1950s, the United States made the decisive turn to use nuclear energy for peaceful purposes. This led to the establishment of the first commercial nuclear power plant in Pennsylvania. The plant used a pressurized water reactor, a type of reactor that uses water under high pressure to keep it from boiling. And what about the fuel types? From the beginning, the United States chose to use plutonium and uranium fuels. Plutonium, a byproduct of uranium fission, and uranium itself, a naturally occurring radioactive element, became the standard fuels for nuclear reactors. But why not thorium, you might ask? Thorium, another naturally occurring radioactive element, was indeed considered. However, the decision to stick with plutonium and uranium was based on their proven efficiency and the existing infrastructure for their production and handling. Thorium, although abundant and potentially safer, would have required a significant investment to develop the necessary infrastructure. As we move into the 21st century, the focus has shifted towards developing safer and more efficient nuclear technologies. Enter the molten salt reactors, small modular reactors, and nuclear batteries. Molten salt reactors, or MSRs, use a mixture of salts as both fuel and coolant. This allows for higher operating temperatures and consequently higher efficiency. Small modular reactors, or SMRs, are compact and scalable versions of traditional nuclear reactors. Their small size and modular design allow for flexibility in deployment and reduced upfront costs. Nuclear batteries, on the other hand, are devices that use the energy from radioactive decay to generate electricity. These batteries are being developed to utilize low-yield nuclear waste, turning a problem into a solution. So, what have we learned? We've journeyed from the inception of nuclear energy in the 1930s through the development of the first functional nuclear reactor in the 1940s. We've looked at the establishment of the first commercial nuclear power plant and the decision to use plutonium and uranium fuels. We've explored the exciting developments in nuclear technology, from molten salt reactors to small modular reactors and nuclear batteries. Nuclear energy, with its promise of virtually limitless clean energy, has come a long way. And with the advancements being made, the future certainly looks bright. Now, after exploring the origins and advancements of nuclear energy, let's put it in perspective by comparing it to renewable energy sources like wind and solar. We'll be examining 4 key aspects: cost, reliability, scalability, and environmental impact. Firstly, nuclear energy proves to be cost-effective in the long run. This is due to its high energy density. A small amount of nuclear fuel can generate a large amount of energy. Secondly, reliability. Nuclear power plants are able to operate continuously, providing a stable source of power, rain or shine. This is a significant advantage over solar and wind energy, which are weather-dependent and can't provide power during cloudy or calm conditions. Thirdly, scalability. Nuclear energy, due to its high energy density, is capable of meeting large energy demands. A single nuclear power plant can power a large city, something wind and solar farms struggle with due to space requirements. Finally, environmental impact. Nuclear energy has a lower carbon footprint compared to fossil fuels, and thus can greatly contribute to combating climate change. In these aspects, nuclear energy holds a significant advantage over renewable energy sources. This is not to undermine the importance of renewables, but rather to highlight the potential of nuclear energy as we strive towards a cleaner, more sustainable future.